All right, if you're gearing up for the AZ-305 exam, you already know that Azure Kubernetes Service, or AKS, is a huge piece of the puzzle. But let's be real, how do you go from just deploying a cluster to actually designing a solution that's ready for the real world? Well, in this explainer, we're going to build that architectural blueprint together.
It's one thing to follow a tutorial and get a basic cluster spinning. But the real job of an architect is answering this question. We're not just trying to run a few containers here. We are building a system that has to be resilient, super secure, and manageable, especially when things get chaotic. And that's exactly what we're going to break down.
So with all these different technologies and choices, how do we find our way? We use a compass, the Azure well-architected framework. We're going to filter every single design decision through its 5 pillars: reliability, security, cost optimization, operational excellence, and performance efficiency. This framework is what helps us turn a laundry list of options into a smart, cohesive strategy.
Let's start with those first 2 pillars, reliability and performance. How do we build an AKS cluster that can handle whatever our users throw at it? We need a system that doesn't just stay online, but one that performs beautifully, even under serious pressure.
AKS has this really clever way of handling scaling at 2 different levels. It uses 2 key components that work together like a perfectly coordinated team: the horizontal pod autoscaler and the cluster autoscaler. Basically, one scales your app, and the other scales the machines it runs on.
So, first up, we have the horizontal pod autoscaler, or HPA. Think of it as the manager for your application. When it sees that the CPU is working too hard, it just says, "Hey, we need more hands on deck," and automatically adds more pods to share the load. It's all about scaling your application out within the existing space of your cluster.
But what happens when there's no more room? What if all your machines are full and the HPA needs to add another pod? Well, that's where the cluster autoscaler jumps in. It sees those pods waiting for a home and automatically adds brand new virtual machines, or nodes, by scaling the underlying VM scale set. It's literally adding more infrastructure to meet that growing demand.
Now, just scaling up and down isn't enough for true reliability. If you want to hit that 99.95% uptime SLA, and that's the one that Microsoft actually puts money behind, you have to design for the worst-case scenario. And I mean a really bad day, like an entire data center going offline.
And here's exactly how we do that. By spreading your AKS node pools across multiple, physically separate availability zones within an Azure region, you're building in some serious resilience. We're talking separate buildings with their own power, their own cooling, the whole shebang. So if one zone goes down, your cluster and your apps running in the other zones just keep right on chugging along.
Okay, our cluster is resilient, which is great. Now let's make it secure. Because a resilient cluster is important, but a secure one is absolutely non-negotiable. We've got to think about access from 2 different directions: what the cluster itself can access, and of course, who can access the cluster.
We can really simplify this whole security puzzle by thinking about it in these 2 directions. Inside out is all about your cluster needing to securely talk to other Azure services. And outside in is for your developers and operators who need to securely manage the cluster itself.
For that inside-out access, we want to get rid of secrets and connection strings in our code. Just don't do it. Instead, we use managed identities. Now, specifically, user-assigned identities are the way to go here because you can create one single identity, give it access to all the things it needs, like a container registry and a key vault, and then just assign that one identity to your cluster. It makes managing everything so much easier.
Now, for outside-in access, the #1 rule is to avoid local Kubernetes accounts like the plague. The absolute best practice is to integrate AKS with Microsoft Entra ID. This lets you use your normal corporate logins and groups, and then you can use Azure role-based access control to give people really specific permissions to the Kubernetes API. It's all centralized, it's auditable, and it's secure.
But what about the secrets that your applications need inside the pods, like TLS certificates or API keys? For that, we use the Secret Stores CSI driver to mount them directly into the pod from Azure Key Vault. Now, CSI stands for Container Storage Interface, and what this driver does is kind of magical. It makes secrets from Key Vault just appear as if they were files inside your pod. The secret never lives in your container image, it never lives in your YAML files, it's injected securely only when it's needed.
So, we've got a cluster that's reliable and secure. Awesome. Next, we need to make sure we can actually manage the thing without pulling our hair out. This is all about operational excellence, making it repeatable, easy to manage, and compliant with all our company rules. And that really starts with a solid networking foundation.
For any serious enterprise setup, the hub-and-spoke network topology is the gold standard.
As you can see, your AKS cluster lives in its own spoke network, and that connects back to a central hub that has all your shared stuff, like a firewall. And for the networking inside the cluster, Azure CNI Overlay is the best choice. It's super efficient because it gives your pods IP addresses from a totally separate address space, which means you won't accidentally run out of IPs in your main virtual network.
To lock down our network traffic, we control it at multiple layers. First, all incoming traffic, we call that ingress traffic, has to pass through an application gateway with its web application firewall turned on. Think of it like a bouncer at the front door, blocking all the common threats. Then, once traffic is inside the cluster, we use Kubernetes network policies to set up strict rules about which pods are allowed to talk to each other. It's a total zero-trust model. Now, this right here is a core principle of modern IT operations. We have to move away from writing manual scripts that tell the system how to do something. Instead, we embrace infrastructure as code with tools like Bicep or Terraform. We write a template that just describes what we want the final cluster to look like, and we let Azure figure out how to make it happen.
And GitOps takes that idea even further, but for the applications running on the cluster. By using an agent like Flux v2, your Git repository becomes the single source of truth for everything. All your Kubernetes YAML files for deployments, services, you name it. The agent is always watching, making sure the cluster's state perfectly matches what's in Git. And what does that mean for you? No more manual kubectl apply commands. It makes your deployments incredibly reliable and super easy to audit.
And finally, to make sure everyone is playing by the rules, we use Azure Policy for Kubernetes. This lets you enforce standards across all of your clusters automatically. You can set up rules for things like, hey, you can only pull container images from our approved company registry, or making sure every service has the right labels for cost tracking. It's basically automated compliance. Okay, we have covered a ton of ground here. Reliability, security, networking, and operations. So let's pull all of these different pieces together into a single, cohesive blueprint that you can use for your AZ-305 studies. And here it is, the whole shebang. This is what a truly production-ready AKS design looks like. We've got high availability baked in with availability zones and auto-scaling. We have zero-trust security, using managed identities for our services and Azure RBAC for our users. And we've achieved operational excellence with automated, Git-driven deployments and governance that's enforced by Azure Policy. So the crucial point here, the big takeaway, is this. We didn't just pick a random collection of cool technologies. Every single component we chose, from availability zones all the way to GitOps, was selected for a very specific reason, to satisfy the principles of the well-architected framework. This is what creates a solution that's balanced, robust, and truly ready for the enterprise. And that brings us to our final thought. This blueprint is a fantastic starting point, both for the exam and for your real-world projects. But you have to remember, a great cloud architecture is never static. It's never really finished. It has to evolve. So the question for you is, as your requirements change and as Azure keeps releasing new capabilities, how will you adapt and improve on this design? That's the ongoing challenge and the fun of being a solutions architect.